We're about to get started on a series of videos on systems of equations, and I wanted to start us off just with one video, just kind of introducing what a system is, what we're trying to do with these guys, all those good things, and then we'll get into some of the deeper details in our upcoming videos. So basically, a system of equations is when you have more than one equation going on at the same time. It's got to be at least two, but it might be two equations, it might be three equations. You might have only two variables, you might have three variables or four variables going on, but the key is that you have more than one equation at a time. Now, what does it mean to solve a system? Like, what does your answer look like? Well, let's unpack that a little bit. We know for individual equations, we know what a solution to that would be. It would be a point like x, y, for example, that would make the equation be true. So we know that already. But a solution to the system is going to be a point like that, like x, y, or whatever, what have you, that makes not just one equation true, but all of them true at the same time. That one x and y value make all of them true. So let's look through just a brief example. We're not going to go into a lot of detail, but we'll illustrate what this actually means. All right, so let's take the system y equals 2x minus 1 as one equation and 3x minus y equals 6 as another equation. So together this makes a system of equations. So let's just for a moment just look at the first equation. Just ignore the second one for a moment. Y equals 2x minus 1. What would be one of the many solutions for this guy? I'll just make a few up. Maybe like 1, 1 would be a solution to that, because if you plug in 1 for x, you get out 1 for y. You might have 4 comma 7. That's a solution, because if you plug in 4 for x, 2 times 4 is 8. 8 minus 1 makes 7. You could have negative 5 comma negative 11, meaning if you plug in negative 5 for x and negative 11 for y, you get a true statement there. Okay, but now let's go a step farther now. So what are all of these solutions to the system? I don't know. Let's check it. Do one or all of these make the second equation be true? Let's try it out. Let's try 1, 1. 3 times 1 is 3. 3 minus 1, which is your y value, would be 2. 2 doesn't also equal 6. So even though this is a solution for the first equation, because it doesn't satisfy the second equation as well, that is not a solution to the system. I'll leave it to you to try this, but the second one doesn't work and the third one doesn't work. So you can tell it's kind of hard to find the guy that would make them both true at the same time. Now in our upcoming videos, I'll show you exactly 3-4 different ways of getting the answer I'm about to show you. But I think this one would be 5 comma 9. Now let me check myself on that. Let's see. If x is 5, 2 times 5 is 10. 10 minus 1 makes 9. Awesome. So that means it works for the first equation at least. We still have to try the second one. Let's try this. 3 times x, or 3 times 5, is 15. 15 minus 9, sure enough, is also 6. So you see how this one satisfies both of them. It's one point that satisfies both of the equations. Now, it's a whole other question how I knew that. All right, and there's a few different methods that we can use to get an answer like that. I used one of these methods to get that answer for you. So even though we're not going to go through them in this video, I will at least show them to you. Here are the methods that we're going to look at over the next few videos to solve systems of equations. All these are good methods. Sometimes some methods are more appropriate than others, but they all are good methods to know. One way is you can solve systems by graphing. I won't go into a lot of detail, but basically you could graph this equation and you could graph this line, graph both of the lines. There's a way to find the solution to the system based off of the graphs. And there's also probably the most popular method of the three is the second one. This method here called substitution. That's a very popular method for solving systems. And then there's also a third method called the elimination method, but if you pick up 5 different textbooks, the last method could go by 5 different names. Some textbooks call it the elimination method. Your textbook might call it the addition method. Those are probably the 2 most common names it goes by, but just be aware the last one the name varies textbook to textbook. So your textbook probably has one of those 2 words there. So we're going to look through all 3 of these methods over the next few videos. Hopefully you'll stay with us to watch all of these. And anyways, hopefully this helps you understand what a system of equations is just a little bit better.